Now chapter 8, section 2, types of chemical reactions. Now we will discuss 6 types of chemical reactions. If you remember, chemical reactions means new substance produced. So now, what are the types of chemical reactions? So the first one, synthesis reaction, which is mean combination. Synthesis means combination reaction. So in this reactions, 2 or more substances combine to form one product. So 2 or more substances combine to form one product. So the general formula for synthesis reaction is, these are the reactants that combine with each other to form one product. So this is the general formula for synthesis reactions. So again, in synthesis reactions, one product. So in any chemical reaction, if you find one product, so the type of this reaction is synthesis reaction. An example of synthesis reactions: lithium reacts with oxygen to produce lithium oxide. And here you have to balance the equation. So 2 substances combined with each other to form one product. Or here the state is solid, gas, and solid. Or for example, carbon reacts with oxygen gas to produce carbon dioxide gas. So 2 substances combine with each other to form one product. So these reactions are synthesis reactions. So the first one, synthesis, means combination. 2 or more substances combine to form one product. So in any chemical equation, if you find one product, so the type is synthesis reaction. So now the second type. So this is the first one. Now the second type is the reverse of synthesis, which is decomposition reaction. Decomposition means breaking down. So here, single compound undergoes a reaction that produces 2 or more simpler substances. So here, single compound, so it contains one reactant. So in the equation you have one reactant that breaking down to produce 2 or more simpler substances. So the general formula for decomposition reactions is, here you have one reactant decomposes 2 simpler substances. So here the general formula for decomposition reactions, one reactant. So, in any chemical equation, if you have one reactant, it means a decomposition reaction. You have to know that most of the decomposition reactions need energy to occur. This energy, it's as heat, or which represented by delta or triangle, or electricity. So, an examples of decomposition reaction, the decomposition of water. Decompose to simpler substances, which is hydrogen gas and oxygen gas. So this reaction need energy as electricity to occur. So here we add electricity. So here you have one reactant. So it's a type of decomposition reaction. Another example of decomposition reaction, for example, calcium carbonate decomposed to calcium oxide and carbon dioxide gas. And this reaction need energy as heat to occur. So again, in this equation, you have one reactant. One reactant means decomposition reaction. So again, the second type of reactions, decomposition reactions, which is mean breaking down one reactant decomposed to simpler substances. And these reactions need energy to occur. And this energy, it's as heat or electricity. So, if you observe the decomposition reactions, the reverse of synthesis reactions. Here, two substances combine to form one product, and here, one reactant decomposed to two simpler substances. Now, the third type of chemical reactions, single displacement reaction. Displacement means replacement. So in this reaction, one element replaces similar element in a compound. So, displacement means replacement, which is mean one element replaces similar elements in a compound. So here, the reactants are element replaces similar element in a compound. So here you have element plus compound, and the products element plus compound. So what happened in this reaction? Here, for example, an element A or X and compound A, B. What are the products? Here, the rule is one element replaces similar element in a compound. So if the element is a metal, replaces the metal in the compound. If non-metal, replaces non-metal in the compound. So for example, if X is metal, this is a compound. As you know, for ionic compounds, we write the formula for cation, which is carry the positive charge, and anion, the negative charge. So here, if you have metal carry positive charge. So it will replace A or B. The rule is element replaces similar element. So if metal replaces metal, positive replaces positive, negative replaces negative. So here X is a positive, so it will replace A in the compound. So instead of AB, the compound is XB plus A.